Here we go. Binomial. You're going to use a CAS. When you see these type of questions, you use a CAS, but you need to know when to use it. This is called binomial. Distribution formula. For reference, if you want to find the probability of something, by hand, it is combinations, nx, probability of that thing occurring, 1 minus p to the power of x. So right here, this means combinations. This means n number, total number. This represents probability of what you want. This is probability. Oops, sorry, that should be n minus x of what you don't want. This is only if you want to do it by hand. Okay? All right, let's do the first problem together. So you only need to know two things, binom PDF and binom CDF, when you're using the calculator. So binom PDF, on your calculator, essentially, it's doing this, that formula. So you just need to know when to use the formula. That's what binom PDF is. Binom CDF is when you're doing multiple ones of that. So an example is if I told you to find the probability of x greater than or equal to 3 and the number of trials that you had was 6, then that means you would have had to do probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5 plus probability of x equals to 6. That means there are 4 binomial PDFs that you have to do. It takes too long to do. So you have to do binom PDF for this one, 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 and then add them all together. That takes too long, so you can do it all in one go and just type binom CDF. Okay, so here we go. That's the very quickest theory that I can go through for you. Your job is to identify when you actually have a binomial problem. Okay, so do you need to know the rule? That's for next year. This year, you don't need to because we're not asking you to do it by hand. We just want you to use on a CAS. So there's only 2 things you're using. So here we go. Let's do the first problem together. Probability of winning a game is 0.25. So you either win or you don't win. 0.25, you win. 0.75, you don't. So you got 25% chance of getting what you want, 75% chance of not getting what you want, right? That's a hint that it could be binomial because there's already 2 potential outcomes. Binomial means bi meaning 2. But then how do you know? It's when they tell you this. They say that winning a game is independent. So that tells you that every probability is consistent. It's independent. Therefore, you can assume this. 0.25, 0.75, 0.25, 0.75. Okay? And it can carry on. So that's 2 branches. In our case, we're not playing 2 games. We're not doing game 1. This is game 2. You need to go all the way, draw a tree diagram till you get to game 10. That's the long way of doing it. This is when you should know to use binom PDF or CDF. Okay, this is a binomial problem. So it says Ben plays 10 games. So now you know it's 10 games. So n equals to 10. We know that the chances of winning a game, they said is 0.25. Those are the only two informations you need if it's a binomial problem. Okay, so you can flick back to this rule that I just wrote just now. You got n, you've got p. You're now just needing to know how many of those successes do you want, which is x. Okay, so here we go. We go back to this one. Now they're telling you, find the probability he will win exactly 4 times. There we go. Now we know. X is equal to 4. So you can do this either by a tree diagram manually. You can say chances of winning, then chances of winning, then chances of winning, then chances of winning, and multiply them all together. In this case, there is only one way, so you don't have to do combinations for it, because you can see there's only one way to win exactly 4 times. And then, actually, I'm wrong. There is combinations, because it doesn't have to be in order. But there's 10 games in total. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 other games that they're losing. Now, the problem with this one is, whilst you know that's 0.25 times 0.25 times 0.25 times 0.25, 0.75, 0.75, 0.75, 0.75, 0.75, 0.75, you don't know the order. There's many different ways that you can write them. So that's why the quickest way is to type on your CAS. Binom, PDF. Here we go, let's go binom PDF. Whoops, not there. On your CAS. Menu, probability, distributions. So on your calculator, go menu, probability distributions. And if you scroll all the way down, you've got 2 versions there. One's binomial PDF, one's binomial CDF. In our case, we're doing PDF. Why? Because they said exactly 4 times. They didn't say more or they didn't say less. Number trials, we have 10. So there are 10 games. What's the probability of winning a game? 0.25. How many games do I want to win? I want 4 games. Press OK. And that's my chances. Okay, so as you're doing this, learn to use that PDF function. Again, if you wanted to do it by hand, the rule would have been n, which is 10. You want 4 wins. Probability of success is 0.25. You need 4 of them. And probability of failure would have been 6. That would have worked as well. So if you did this by hand, that's what you would have got. Combinations. 10 choose 4. 0.25 to the power of 4. 0.75 to the power of 6. Same answer. That's the manual way. So you don't need to do it through the formula. You just need to do binom PDF. All right, so I'm going to screenshot this so that you guys can look at it when you get to binomial. So here we go. I'm going to zoom out again. So yesterday's confidence in binomial, a lot of you guys said you're about a 3, 30% sure that you can do it. This is all you need to know. That's it. Binom PDF. Okay? Let's try one more. So that's binom PDF. You're just using PDF or CDF. So next problem is likely a CDF problem. So according to a survey, 30% of employed women have never been married. Okay, so you got a 30% chance of not being married. Again, same thing, 10 employed women. So you got 10 of these women are selected at random. The probability that at least seven have never been married. So here we go again. How many times are we picking? We're picking 10. What's the probability of picking someone that's not going to be married? 30%. What's my X? I'm looking for at least 7. So I'm saying I want 7 or more. So it could be 7 unmarried 8 unmarried, 9 unmarried, or 10 unmarried. So here we go. This one would clearly be a binomial CDF. Now you can do PDF, it's just longer to do. So binomial CDF, here we go, back to your calculator. Menu, probability, distributions, and then binomial CDF. Here we go, binomial CDF, asks number trial, same thing. I've got 10 people that I'm picking. Chances of getting a unmarried, 0.3. Lower bound, I want from 7 people that are unmarried or more, which is 10. And that's how you get it. Okay, so your answer for this one should have been 0.0105, but because it says round to 4 decimal place, it should be 0106. So here we go. Binomial CDF, here we go. Which one is our 2 answers for question 1, question 2? Question 1 should have been A. And then question 2 clearly should have been C. What I just showed you here, that's the only 2 types of questions you're going to get in your exam. There's only 2 types, CDF or PDF. This is not I wouldn't say it's a hard question. I think it's just whether you practice enough. So we've got, so far, I've given you this sheet. You've had a practice sheet. You've also got a skill sheet. It comes with solutions. And then I just went through again what you actually really need to know for your exams. It's really just those 2 functions. Binomial CDF, binomial PDF. And how do you know when you have it? That's the type of questions. So when I'm marking the exam, I'll know who has practiced and who hasn't, because it's pretty straightforward on how to do it. Cool? I'll stop there just because yesterday